So hello guys, today we are going to discuss breadth first search or level order traversal. So basically BFS starts as B starts before D, DFS, depth first search. So BFS is from queue and DFS is from stack. Um, so we have BFS which we use queue, and DFS is we use stack. So basically what is BFS, breadth first search? So for example, if we have a graph something like this, the 0, 1, 3 and 2. So instead of going deepest, that is 0, 1, 2, we go 0, 1 and 3 and then 2. So this is the breadth first search. In tree, it's called the level order traversal. That is, instead of going deepest, that is 12, 10 and 14, we go level by level. That is breadth. We traverse by breadth. So the output would be 12, 10, 30, 14, 25, 40 and 50, something like this. So, when are the different conditions we need to apply the BFS? So, whenever there is something, we say that question asks that find the shortest distance to a destination node. So, in that case, we need to apply this BFS, because what happens is if we go deeper and deeper into the graph, so in that case, the node which is the destination node, which might be adjacent to us, might get missed. So we traverse all the neighbors in the breadth first fashion, and then we go the further level up. So there is actually basically a template for the breadth first search in all the questions. So there is a lead code hard problem called the race car. Um, yes, so this is can be solved using the BFS template. Then there is again a binary tree traversal, that is the level order traversal. Then this can also be solved using the BFS template. So that's what we are going to see today. So in the BFS template, what we have is we'll be taking a queue. Then we'll be pushing the first or the start node onto the queue. And this visited is basically for the graph case. For the tree case, we will not take this. Then we will go into a while loop, which is for traversing whole of the tree or the graph. Then we are going to find the size of the queue, and we are going to traverse the levels or all the nodes at the levels using this for loop. So basically, this is the template where we have a while loop, we have a for loop, and before the for loop, we have to calculate the size, and then we have to go through all the nodes in that particular level in this for loop. After this for loop, we are going to increment the level. So that's the very basic and always to be followed template. So inside the for loop, which is at the particular level, we'll get the element from the queue, and this is also very much important. We cannot do this outside the for loop. And then we will be traversing all the children of a particular node. If it is a tree, then for that particular tree, we are going to traverse all the children, and we are going to insert them in the queue. We are going to push them in the queue. So let's see this with our example of a binary tree traversal. So the question on the lead code given is this, that we have a tree which is represented by the tree node, struct tree node, and we are given something as a root to the tree, and we need to return the two-dimensional array, that is a vector, which represents every level. So one vector 3 represents one level, 9, 20 represents another level, 15 and 17, 7 represents another level. So how we are going to solve this problem? So this is a breadth first search. We'll be going to apply our BFS template. So in BFS template, we take the queue, and this is for the output. That is, at every level, we are going to take a vector of int, and for the complete output, we are taking a two-dimensional vector. Then we are going to push our uh, root onto the queue, and we are going to push the value of the root node, that is 3, onto our out. Then for traversing the whole tree, we are going inside a while loop, which actually checks until the queue is not empty. So this is our the BFS template. We are going to calculate the queue size, and we are going to traverse all the children of at that particular level. So what happens here is, if let's suppose I have inserted 3, then the queue size is 1. So I'll go in this for loop, that is I equal to 0, I is smaller than 1. Then f becomes 3, then I check that whether I have left of 3. So yes, I have left of 3. I'll insert it in queue, and I'll insert it in the level 1D. And then if it has right, that is 20, so I'll insert 20 as well. So 9 and 20 are there in 1D vector level. And then because this is for only size 1, I'll come outside if level size is greater than 1. So I'll just insert it in the out, and then I'll clear the queue. Now our queue contains 9 and 20. So it goes inside, it checks sizes 2, here it is 2. So f becomes equal to 9. So f doesn't have left, f doesn't have right. So it goes here. So level size is 0, so nothing pushed. Then it again goes back. Now the queue has 20, so it popped 20 out, and here it popped 20. Sorry, it will go to this for loop. Then it checks that what's the left of 20. So left of 20 is 15. It pushes. Right of 20 is 7. It pushes and pushes onto the queue and also pushes onto the level. And we have the complete like uh, tree onto the output. And then since 15 and 7 are also in the queue, it will just go in the queue, that is while queue is not empty, it will check 15 has any child, no, 7 has any child, no, and it will return out. So basically these are the only three steps to remember in BFS template, that we have to take a queue. For the complete tree traversal, then we have to take for loop, which traverses till the size for each level traversal. And inside this for loop only, we have to remove the queue front, and all the processing has to be done inside this for loop only. That is, if it has a child, then push in the queue. If it has another child, push it into the queue, and similarly, and so on. So let us just go into this as well. So though this I'll have the complete discussion in another video, but I was just showing it that this can be solved. So this is another example of a DFS template. We have a queue, we taken a size for all the levels. We are like the popping of the queue is done inside the for loop again. See here, and then we are checking that whether we have any entry that like satisfies the condition, that is to be pushed inside the for loop only. So queue is actually populated and popped inside the for loop. Levels are incremented outside the for loop, and this is how the level or traversal works. So that's all for this video. Yeah, thanks a lot.